So limiting reagents could really actually have almost been part of the stoic lesson as well. The only difference is that these questions you're going to be given, usually it's two, sometimes three reactants, but more often two. And what happens is you're given two reactant masses. So then the question is which one are you going to use to predict the products? So in these questions, you're always doing, given the reactants, what would the product be? Okay? So this has more practical applications. It makes more sense that you know what you put in. Okay, tell me how much you're going to get out. Okay? So the limiting reagent, so limiting implies that's kind of the boundary, right? It's limiting how much product can be produced. So it is going to be the first reactant in a chemical reaction that is completely consumed. There is only one limiting reagent because once it's used up, then the reaction can't go anymore, okay? So again, when we first teach you about types of reactions, we don't really talk about the conditions needed for a reaction to occur. So again, you can't just put in random amounts and expect things to go as predicted. You need to make sure that you have more or less of a certain reactant. So when you guys did that lab in grade 10 and you put aluminum foil in the green solution, what happens is the teacher knows they use more than enough aluminum. So what it looks like is the copper is sticking to the aluminum foil, but what's happening is that the aluminum foil is what we call excess. So there is more than you need of the aluminum foil, so it is not getting used up, okay? So sometimes when you have just a plain stoic question, you guys don't have to draw this. When you have a plain stoic question, it'll say reactant A has 5 grams and there is an excess of reactant B. That's just a way of standardizing a question. There is more than enough of the other reactant, so we're not worried about it. Similar to that lab you guys did. There was more than enough aluminum foil, so we didn't really care. The limiting reagent in that case was the copper 2 chloride. So sometimes we do this lab where just to get you to visually think about a limiting reagent. So we have a control here, water and solution, nothing happens. This is double displacement, so calcium chloride mixing with sodium sulfate. So if you have an increasing amount of calcium chloride up to 10 and 10, then F should be the tube that gives you the most product. So it makes sense. The lower the amount you have, then the lower product you're going to get. If you have this bottom has 10 milliliters of sodium sulfate, it's the excess reagent. There's more than enough here. The calcium chloride is determining how much product can be produced. Okay? So we're going to do the same thing that we just did. If you're given masses, you have to change those into moles first. So we are going to use stoic again, and then you can use the stoic ratio to figure out which the limiting reagent is, and then also to figure out what how much product you get. Okay? So it's you are like we already did basically this, except now we have 2. We're even going to set up the questions the same way with like a chart, again, except now we'll be able to fill in 2 columns. Some of the questions are similar to the stoic questions. Some are already in moles. So if you're given a question, although this is terrible typing, but this equation, the NaNO3 can go up there. So now you're given 2 moles of AgNO3 and 2 moles of NaCl. So now you're given 2 amounts. So which one do I use? Okay, so you have to figure out what the limiting reagent is first. When we do questions, like big questions, sometimes it'll say balance the equation, depends. Then it will say determine the limiting reagent. Then it will say how much product can be produced. In this case, you're going to do both, okay? So it's really, I'm not going to make you try to figure it out. Do I have to do limiting reagent? I'll tell you, okay? So what you can do is the same thing that we did before. Write it like a chart underneath. And there are plenty of questions like this one. Do AgNO3 and NaCl have the same coefficient? Yes, they're both 1. So then they have the same mole amount. So if they're the same mole amount, that makes your life easy. There isn't a limiting reagent. It could be either one. Who cares, right? Actually, I'm not even going to write amounts. I'm going to write moles. Chemists are lazy. We usually say LR. I'm at a space, so I definitely wrote LR, okay? So equal moles, equal coefficients means they react, or if you prefer, they're used up equally. Therefore, doesn't matter. So there are plenty of times when we take care of this, and this is true, and you don't even know it because you haven't considered the quantitative side of a chemical reaction yet. Okay? But then this one, it's not the same. So the general mole ratio is 2 to 1. So we have to take that into consideration when we're figuring out how the reaction is going to work, because that means you need twice the amount of hydrogen compared to the amount of oxygen because of the coefficients, the mole ratio. So some of you are doing the ratios in your head, which is great, but you can always do this same thing every single time. You have to figure out which one is going to be used up first. So when we do the question that has actual gram amounts, we need it to be able to compare to each other, okay? Again, we'll just write short forms. So if you're figuring out which one is the limiting reagent, if we need to figure out how much is actually going to be used. So if you have 2 moles of this, how much is actually going to be used? 2. So if you do, 2 divided by 2, you get 1. Here you have 2 moles. How much is going to be used? Only 1. So you just take the mole amount and divide by the coefficient. And again, possibly you could do that in your head, okay? So at first, it looks like they're the same, but because you use twice the amount for every cycle of a reaction, then you're actually using up more of this than you are of oxygen. So this one is a smaller amount, which means that it gets used up first. So it's got the smallest amount, or that limits how much reaction can occur. And again, we always are going to take the grams and change them into moles. Never compare grams. Okay, so more often than not, you're going to get a for real question. So really, that's all that's next is an example. Given the reaction, in this case, I happen to include the aqueous and liquid and whatever. Again, that doesn't affect the stoic or anything like that. If you react 3.2 grams of hydrogen sulfide and 4.55 grams of sodium hydroxide, now technically you're given two amounts, so that's a clue. You're going to do limiting reagent, but like I said, the question will be very specific. Part A, find the limiting reagent. Part B, blah, 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 do whatever else, okay? So again, when we do these questions, this is a lot of work, and then these two will be much shorter. And then we're not going to do this, okay? Everybody's brains have had enough. So, and the limiting reagent part of it is much more important. In a lot of ways, who cares about how much excess is left over? Because we're going to figure out the limiting reagent and then use that to predict the products, which is really, in a practical way, what you would want to do, right? Okay, so we're going to set up the question the same way that you did before. We are going to write the equation. We're going to write down what we're given. And find moles, okay? So again, you decide for yourself. Do you want to show your work for molecular weight? Are you good at it enough now that you don't need to do that? Do you need to show your work for moles? No, I don't want to. I'm just going to write the answer in. It really sort of depends. Like, you know, you guys decide what's what, okay? But we do have to do both. So we have to do H2S. So sulfur's 32. I'm gonna cheat and round. Plus 2, which is 34. What's it called? Sodium is 23 plus oxygen, which is 16, plus 1 is 40. If you want, stick this in here. So what's this now? Like the fourth time we've done something like this, right? Mass, molar mass, moles. So you can see that we don't often do entities and atoms and ions because it's not really practical. if the coefficients were the same, then you could say, okay, H2S is the limiting reagent. It's got the smaller amount. It's going to be used up first, but they are not the same. So then we have to divide by the coefficient to see how much is being used every single time you do a reaction. So if you like the chart way, you can make a row that says LRR like we did in the other one. Okay, so at first glance, if you just did the moles, you'd be like, oh, this one's used up, it's smaller. However, because every reaction requires 2 sodium hydroxide moles, then this is being used twice as fast. So then when you divide by the coefficients, now this is the limiting reagent because it's got the smaller amount and it's going to be used up first. So you can write a sentence. Some people, like to circle it, whatever you want. Again, make sure you answer the question. If it says determine the limiting reagent, make sure you've got a sentence or something. Therefore, the limiting reagent is, you can even write LR. Usually the math is good enough. I don't make you explain it, but if you want to, in your note, write down it's the smallest amount, so it's used up first, so you know when you're doing stuff later. Okay, so we've answered A. So tomorrow when we do percent yield, usually we'll pick one of the products. This question happens to make you do both, which is fine. But normally if you have to do percent yield next, then you would just do one. So why is the limiting reagent important? If it runs out first, and once the reaction is gone, once it is gone, the reaction is going to stop. One of the reactants is gone. There is no more left. So logically, if the reaction has stopped, can more of the other reactant react? No. If the reaction has stopped, can more product be produced? No. Get out your highlighters. So the moles of the limiting reagent are going to be used to predict to determine or predict how much product is produced. How are we going to do that? Just like you have already done, okay? Using Stoich. So similarly, let's say you guess, you've got a 50-50 chance, right? Normally most reactions have two reactants. If you pick the wrong limiting reagent, just keep going. Who cares? Then I'll just take off a teeny weeny bit of marks, and you can just keep going. So we are going to use the moles of the limiting reagent when we do B and C. Which is on the back. So like I said, similar to Stoich questions, A is a lot of work, and then B is not so bad. But the big thing is Na2S is a product. We're going to use the mole amount of the limiting reagent to predict it. So these are two different ways of saying the same thing. We're going to use the mole amount of the limiting reagent to predict the mole amount of product produced. You're going to use a Stoich ratio where the X is the unknown is the product moles, and the known values will come from the limiting reagent. So when you look at the table you made previous to this, there was just one mole amount. You were like, okay, just use that in the ratio. Now you have to decide. So that's why we find the limiting reagent. Whichever one is used up first, that's the one we're going to use in our ratio. So back to here. Take a look at your table. Where is the mole amount of the limiting reagent? It's right here. That's not a highlighter. So if you want to emphasize that for yourself, even write it in there. If If the other one has more left over, then who cares? It's not going to be used up. This one is. And follow the same principles. Always compare moles, never compare grams. We're still going to use the coefficients. So this is just kind of an extension of doing stoic. Okay, so how many moles? What's the question want? Na2S. Its coefficient is 1. So again, these are pretty nice coefficients. Basically, all you have to do is divide by 2 because this is the 1 down here. But I can write it. Usually, I like to be more specific. The question just says how much. It doesn't really say moles or grams. So this would again, usually I would be like, determine the number of moles or determine the mass. But this would definitely be a case where you could be like, should I do moles? Should I leave it as mass or whatever? So we'll just keep going. Okay, so whether you're a triangle person or not, you can decide how you want to do this. Same thing with the molecular weight. You can choose to show your work or not. Okay, so then we're going to do the same thing for water. So again, usually you're only going to have to do one of the products, but we can do both, okay? So how much water? Its coefficient is 2. Again, those of you that are good at this, doing this in your head, you would recognize both coefficients are the same, so the mole amount is the same, but you can do this ratio thing every single time, okay? You don't have to guess. And then I'll just change it back into mass. The question is ambiguous, so definitely make sure, call me on it. Say, yo, what am I supposed to do here? Okay, and we're going to stop there. So any of the questions in the homework, if it talks about excess, don't do that, okay? So number 1 is a weird chart question. So you might even want to just start at number 3, okay? Because it definitely has a column of excess, but the solutions are in there in the file, so just in case you're looking at them, it's up to you.